stand away from the door.
Okay, good evening, ladies and gentlemen, and welcome to this Monday evening live session. And we are going to go deeper into some fundamentals of statistics and some practical stuff, how we can implement it in our Lean Six Sigma projects and our problem solving approaches. Okay, so before that, let's welcome the new members in the group right now. If anybody is new in the room right now attending the session first time, just type me in the chat box. First we will welcome you and then we'll start our session. Just type me in the chat box. Okay, Sharon is there. Who else? Everybody, the people who are new in the room attending the session first time, just type me in the chat box. Yeah, and others, please type welcome new members in the community. Superb. Welcome, welcome, welcome. Yes, thank you very much, Santoshji. Great. Super, super, super. Amazing, amazing. So fantastic. So let's start with my formula, which I always inculcate, and that formula is the fastest way of achieving mastery in any skill is this formula, right? Which I always inculcate, always preach. This formula is learn, implement, and teach. Okay, why background change? Something new, We are into change management, so we are also आज थोड़ा सा CSSC का background देख लिया. Actually, my camera is under repair, so my original camera. So I'm just a second camera which is not my original camera. So I'm just doing some other stuff which looks better. Okay. Anyway, coming back to learn, implement, and teach. This is the fastest formula to achieve the mastery in any subject. You want to master Lean Six Sigma? Go through this formula, learn, implement, and teach. Now, the today's topic, lot of seniors would have gone through this topic multiple times. For the new members, it might be completely new, right? But what I believe is this. Okay, if let's say you are at green belt level and you are very new, let's say in the system. So today you will learn the concept, the same concept. I'll explain the same concept, same statistics, the basic fundamental, which will make the foundation stronger. So the green belt people will learn. The black belt people will same concept, but their perspective will be of implementation. How do I implement it? Of course, green belt also should think like that. But for the green belt, for the new members, it's a first learning concept. It's a learning stage. We are learning new concept. Black belt people will try to see that, okay, so this is the concept. How do I implement it in my project? How do I implement it in my process? And the master black belt and the consulting program people consultants, I would say, these people will see the same concept. How I am teaching. So they will learn in the perspective of a trainer how this concept is being taught, how the background is being created, how the topic is being started, what is the first point, what is the second point, what is the third point. Are you understanding? Because any topic which I cover, there is lot of hard work which goes in, lot of notes taking which goes in, lot of experience which goes in. Okay, so learn, implement, and teach. LIT is the principle. Now, so it's not only applicable in Lean Six Sigma. You take anything. Okay, you take anything. You're learning, let's say, data analytics, or you are learning to play the guitar. First you learn it, then you practice. Implementation is practice, practically practice it, and then you teach it to somebody, right? Yes, Sharon, this is, see, it is not like first day, every week we take the sessions, we take the concepts which are required for green belt and black belt, okay? So whatever we discuss in the classes will be important for your green belt stuff as well as your black belt stuff. So some way or the other, because every day, every week, new people will join in this, in this entire karma, and we will learn together, right? So for you, it is the first day, and today's topic is very important for the green belt. It will make your foundation very much clear. All right. So everybody clear about learn, implement, and teach strategies. Whenever you learn something new, let's say for example, today we are going to learn statistics, the basic foundation statistics. Okay, sigma and Zigma. So Zigma is a new word which we are going to learn today. So when we learn something new, try to teach it to your colleagues, friends, family members, whoever are interested people. The moment they understand it, that's a confirmation, that's a validation that you have understood the concept. That's why learn, implement, and teach is the amazing way of acquiring any skill faster. Everybody clear? Just type LIT in the chat. LIT in the chat. Just give me a LIT in the chat. Super. Very nice, very nice. Chalo, so today we are going to touch upon some of the fundamentals, and today's fundamentals are about statistics, which is a part of, in the DMAC framework, we start using statistics in major phase. Okay, yeah, no problem, Kalpesh, no problem. That's great that you are in the train and still joining. That shows your commitment. Coming back to the DMAC framework, define, measure, analyze, improve, and control. Everybody knows about it. So in the major phase, see, in Lean Six Sigma, what actually we do is we have a real life challenge. Real life challenge, I would say. What is real life challenge? Attrition is a real life challenge. Machine downtime is a real life challenge. More average call handling time is a real life challenge. Your more defects is a real life challenge. So in Six Sigma, the real life challenge basically is converted into statistical challenge. I'm not using the word problem. You can use the word problem as well, but I'm using as a challenge. Okay, a little positive connotation I'm just giving. Okay, so what we do is a real life challenge. So in the define phase, we define our real life challenge. Accuracy improvement, absolutely, Mukeshji. So we convert that into a statistical challenge in the measure phase. How do we convert that into statistical challenge? In define phase, we ask what is the challenge. In measure phase, we ask how big is the challenge. By collecting the data, by quantifying the problem, we ask the question how big is the challenge. So in the measure phase, basically we use statistics. After that, we solve that statistical problem and we get a statistical solution. Okay. And then that statistical solution, it's converted into real life solution. This is what we basically do in this entire DMAC framework. A real life problem we convert into statistical problem. In statistical problem we solve it by using statistical tools, and that statistical solution we convert into a real life solution. And in this phase where we have the statistical problem and statistical solution, we have to take help of the science called statistics. Yes. So in this DMAC framework, the first time we use statistics is the phase called measure phase. So what we do in measure phase, we collect all the data. And how much data should we collect? At least minimum, type in the chat box if you know. During doing the project, at least how much data we should consider. What is the duration? I'm talking about the, let's say you have a problem. Very good. So it should be at least 1 year data. At least 1 year data. Let's say you have some, some customer complaint. So collect some 1 year customer complaint data. You have some machine breakdown. Just collect machine breakdown. You have the, you have the, what you can say, attrition problem. So collect attrition data of 1 year, right? Whatever, see, more is always better. Don't take 1 month data. That may not be giving you a right, what you can say, amount of information, right? What is 30? Lot of people gave me the answer 30. What is 30? See, 30 is the data according to CLT, central limit theorem. Now today I'm not going to go into that. According to central limit theorem, once you collect the data, at least after 30 data points, 30, 40, 50 data points, you start getting normal distribution of the data. Otherwise, before that, you might get uniform distribution like this, or you might get a skewed distribution like this. To get it to the proper shape of normal distribution, you should require at least 30 data points. That is the statistical thumb rule. That's why a lot of people gave me answer of 30. But what I was asking is, how much data before we collect, for the project, how much data should we collect? At least the duration should be 1 year data. Okay. Clear everybody with this? Just give me yes in the chat box. Clear? So we collect the data, right? And then we use statistics. Now the rule is, understand this, whatever you do not measure meaning whatever you don't have the data of. Simple. I gave this example of decided based on CLT. No, if you want normal distribution data, for example, if you want normal distribution data, okay. Now, why do you want normal distribution data? Because our, our standard deviation, our process capability, our stability, right? Everything basically is based on the area under the curve. Yeah, the CLT stands for central limit theorem, which in short says, as you collect more and more data, it takes naturally a normal distribution shape. Okay. So what is that number? How many data points we should consider? For according to CLT is 30 data points. Okay. Yes. So then if the data is normally distributed, then our process capability and other indices what we calculate, process parameters, those will be more authentic, accurate, precise. Clear? Now coming back to this phenomenon, this is very important. Whenever there is an area in your process which is not functioning properly, listen to me very carefully. I'll give you example of our monthly expenses. That is a very famous example and favorite example of mine. Lot of times, when our salary comes and at the end of the month, we don't know where it goes. Are you understanding? Now, if you want to improve the cash flow, if you want to improve our investment, if you want to improve the control on the finances, start measuring it. Same goes with anywhere. Same goes with your process. In your process, any area which is weak meaning you have more downtime, you have more defects, you have more customer complaints, their first thing you need to check is the measurement system. Are we collecting enough data about it? Are we collecting all the data about it? Very, very important insight. Make a note of this. Because what you cannot improve what you do not measure. That's the fundamental rule of measure phase. If you want to improve that process, start collecting data about it. Merely collecting data will start, having some focus in that area. Do it. You will immediately start getting 10-20% improvement in that area just merely by collecting the data. Don't do anything. Don't do Six Sigma, don't do Kaizen, don't do Lean, anything. Just collect the data. The moment you collect the data, start displaying the data as well. Now we have the Minitab software. You can make a simple train chart. Don't do anything else. You make a train chart, you make a control chart, which we are going to learn in this course. Just merely by collecting data and displaying it, you will start getting, improvement. Are you understanding? Yeah. मुकेश जी, CLT के बारे में अभी मैं आज थोड़ा सा लास्ट में बताता हूँ. ओके, सेंट्रल लिमिट थ्योरम के बारे में. We will do an exercise on this Minitab के ऊपर and then we will understand CLT. ठीक है? Yeah. But nice to see you after a long time. Okay. Now, so the first principle is start measuring, start collecting the data. Okay, just give me a yes in the chat box if you have understood this important principle. Collecting data itself is a principle. Collecting data will empower you. Okay, nowadays they say data is new oil. Okay, now you don't require crude oil, you require data, you require information. Information is the most important tool you have, right? So start collecting it. Now, we also have, now if you don't have the input data, the software cannot do anything. Then again, we'll go back to the old way of solving the problem with the opinion, right? That we don't want. Now, when we start collecting the data, there are three types of data: input, process, and output data. Now, we all know entire process can be structured in input, process, and output. Okay? Yes. So, ज़्यादा data is always better, right? But nowadays we have data collection mechanisms, we have IoT kind of things, we have softwares like Minitab and other softwares. So data analysis has become easier than before. So collect the data, that is the most important thing. Now coming back to types of measures. Input measure, process measure, output measure. All the three types we have to collect the data for. For example, I've taken a very simple example of making a cup of tea. What is the input measure? The water. Now in water, what do I collect? I will collect the quality of water. Is it RO water? Is it UV water? Is it a simple tap water coming from a municipality? Okay. And what is the quantity? So quality as well as quantity. When it comes to milk, whether it is a buffalo milk or a cow milk, which brand, whether it is Mother's Dairy, whether it is Amul, whether it is what exactly is the brand we are using, and what is the quantity we are using. So qualitative data, quantitative data, both kinds of data we can collect as input metrics. Now at this point in time, we don't know whether this will be critical, important data for us or not. We just collect the data. So whenever it is required, it should be available. So in the measure phase, we will make sure that the data should be available. So input, so tea powder, sugar, will collect that data. In the process, we'll collect the data of temperature, how much temperature we are keeping, what is the time we are boiling that entire mixture, how much time the person is stirring the entire mixture. So we'll collect that data. Output is the test on the scale of 1 to 10 we'll measure. Turnaround time is nothing but a lead time. What is the order given and when the delivery was done. Okay. So that kind of, then that even temperature also can be, the temperature of the cup of tea also can be the output measure we can measure. So these are called input, process and output measure. Okay, now in the chat right now, everybody just give me your one input measure of your own process. Okay, in the chat you write like this: I, and give that measure, P, give that measure, and O, give that measure. Just type in the chat box, I'll wait for you. In your process, give me one input measure, one process measure, and one output measure, which can be measured. If you are a BPO, number of incoming calls is the input measure. Are you understanding? Process measure is how much time is taken on an average to handle that call. How many calls are in the process? Output measure could be AHT, average handling time, or how many calls are waiting, how many calls resolved, the query not resolved, that is also output measure, right? Yeah, can you just put that quickly? IPO, input process output. Raw material test reports for mechanical and chemical properties are input. Very good. Hardness of the steel, temperature of the oven, improved hardness of the steel. Fantastic, Santoshi. Very good. Input of 10 jobs per cycle, time per job. Okay, okay or not okay is the output. Very good. There could be some process measures as well, right? New join training is the, yeah, now we are here. Here we are typing what are we measuring? Okay, so new joining, maybe we are measuring the experience of the person. Maybe we are then in training, how much time the training has happened in the process, and then in the output measure, what is the productivity or how much qualitative output that person is giving. Number of breakdowns a month is the input. Daily runtime of the machine, number of on and off, and output. Okay, so okay. Form part dimension, output is CTQ parameter. Okay, very good. Mistake in the document is the input. Processes inform the respective department and head for correction. That is a process, and 100% errorless document is the output. So you will measure the mistakes that you will count. That is the input. Then in the process you can measure the processing time, meaning the correction time. Okay, how many correction, how much time are you taking to correct? And then on the output, what is the percentage after rework? How much is the percentage after rework you have cleared? Very good. So I think you guys got some idea that these are input, process, and output measures where we have to collect the data about it. And how much data? At least 1 year data if you have about it. Okay, super. Now when you collect the data, there could be two types of data. One is called continuous data, other is called discrete data. What is continuous data? Some data can be measured. Okay, some kind of data can be measured. So you can see here measured. Okay, if the data is measured, for example, we say that go and measure your weight. We never say go and count your weight. Are you understanding the difference between these two? Whenever we say go and measure your weight, it comes into continuous category. Okay, when we say go and count, we never say go and count your weight. We always say go and measure your weight. That's why the length, height, weight, all these are continuous data. On the continuous scale we can measure, like 60.1, 60.2, 60.3, 60.6, 60.9, 70, 70.1, 70.2 kg. So on a continuous scale we can measure. Length as well, 10.1, 10.2, 10.3, 10.9, 11, 11.1. So on the continuous scale we can measure. So that is called continuous data. Are you clear? And on the other side, there could be a discrete data as well. Yeah, Santoshji, it is exactly opposite. Count data is the discrete data. For example, how many people sitting in the room? It's called a count data. We never say go and measure how many people are sitting in the room. We say go and count how many people sitting in the room. Whenever we say count, that is called discrete data. 10 people, 15 people, 20 people, 100 people, 200 people. Are you understanding? So count data is a discrete data, measured data is continuous data. Are you clear with this? Just give me yes in the chat box. So how long, what is the volume, how far, all these distance, temperature, pressure, all these are continuous data. And yes, no, how many people in the room, male, female, accept, reject, go, no go, all these are called as discrete type of the data. Clear? Yes? Yeah, if percentage, you should consider as continuous, because it can be measured in on the on the decimals as well. Now continuous data we can measure with the decimals as well. Okay, so generally we can consider percentage as a continuous data. Okay, you can use all the continuous data features for a percentage data. Now in the chat, give me one continuous data in your process and one discrete data in your process. Type in the chat box quickly. If you have understood it, then you can easily able to connect it with your own process. And that is what we do in the live session. Live session is where our understanding goes into the different level, different depth. Give me one example of continuous data in your process. Okay, connect with your own process. Think about your own process. Okay, what is my continuous data? Very good. So temperature and discrete is accept, reject. Very nice. Number of denial. Okay, percentage is a continuous data. Number of denial claims. Fantastic. Is a discrete data. Very nice. Monitoring the temperature. Again, it's a continuous data. Temperature itself. And number of tablets is a discrete data. Fantastic. Fantastic. Dimensions in mm is continuous data. Number of parts is a discrete data. Very good. Bore diameter is a continuous data. Pass and fail, go, no go is a discrete data. Fantastic. Very nice. Production numbers can be a continuous data. Head count, how many people, discrete data. Clear? Turnaround time of the sample report and discrete number of reporting errors. Fantastic. Super, super. Now here, let's say I have a data of the same example of our chocolate weight. Okay, let's say I am a chocolate weight I'm a chocolate company quality inspector, let's say. Okay, and our specification is 10 grams and above only chocolate I have to select. Below 10 grams I have to reject. Okay, so let's say first chocolate I take, the weight is 10.2. okay, this is weight. All right, second chocolate is 10.0, third chocolate is 10.1, fourth chocolate is 9.9. So here I will say accept, accept, accept and reject. Now this first column data is continuous data and second column data is discrete data. Are you clear with this? Just give me a yes in the chat box. Clear? 10 grams is the acceptable limit. Below 10 grams I have to reject it. So if I have the weight data with me, it's a continuous data. But if I have discrete data like accept or reject data, then that is called a discrete data. Okay, so which kind of data are we collecting? That is what it all about, right? So continuous and discrete, very, very important. And always try to always try to always try to convert if possible. If you have discrete data, let's say, let's take the same example. Take the same example of accept and reject. Instead of accept and reject data, you take the weight data. Are you understanding? Don't take accept and reject, because accept and reject may not give you that binary number. No, accept, reject, that may not give you a lot of information. Instead of that, take actual continuous data. With the help of continuous data, you can do a lot of things. You can make a trend. Understand this, huh? What is the advantage of continuous data? You can make a trend. Okay, let's say if I have to make a trend out of it, it will look like this. Correct? If I have to make a trend of a discrete data, it will look like accept. Let's say if I have a different level, reject, then accept and then reject. Okay, so let's say this is accept and this is reject. Then it will be a binary kind of a which will give us very, very limited information. But here I can see whether my trend is going up or trend is going down. Okay, what is the variation? I will make a histogram, I will make a control chart, I will make a process capability. Everything can be done very easily with the help of continuous data. So always, whenever there is a discrete data, try to convert that into continuous data. Another example is pass or fail. For example, if I give you the data of 50 students, out of which 10 students have failed and 40 students have passed. That's it. That much of information you have. Very limited information. Instead of that, if I give you percentage of each and every student, which data will give you more information? Percentage or pass or fail? First is percentage, second is pass or fail. 1 or 2, type 1 or 2 in the chat box. First is percentage, second is pass or fail. Obviously first, right? First will give you each and every person's percentage, the marks. Second is always already pass or fail. But somebody is failed in a very, with a very thin margin, or somebody failed with the 0 marks. Both will be categorized as failed. That is very limited information, right? So always try to convert that into continuous data. So instead of pass or fail, go, no go, try to take actual data on the basis of which you have taken the decision. So take that data. Okay, go one step back and take that data. That will be more informational for us. Okay, very good. Everybody's clear till now, no? Just give me yes in the chat box. Anybody, especially the new people. See, this is very fundamental, and these people, most of these people have already heard this 100 times. Okay, yes, new people here. Very nice, superb, superb. Any doubt, please let me know. I will explain the concept once again. All right, amazing. Now, when we collect the data, okay, whether it is continuous or discrete, then we use the statistics as a science. Now, what is statistics? I have made the simplest formula to define statistics. Exactly. So for more precise information, try to convert that. Okay, if possible, try to convert that into continuous data. That will be more useful for us for further analysis. Okay. Now, what is statistics? Statistics is a science which converts data into information. Understand this? If I show you, list of or what is a complete Excel files full of data, our mind will not be able to comprehend it. But instead, if I convert that into a pie chart, if I convert that into a trend, if I convert that into a control chart, a histogram, then our mind can comprehend it. And that's what exactly is the role of statistics. It collects, analyzes, represents in such a way that we can take out useful information so that we can take some decisions and actions in our business and processes. And that is the role of statistics. Okay, so in the very simple term, statistics is a science which converts data into information. That's the simplest definition. From the information, we deep dive and collect and we get wisdom out of it. For example, let's say, understand this. If say there is a trend like this. Okay, now what we have done, earlier there was a Excel sheet. It was data. So Excel comes here. Excel sheet data. Okay, so what we have done, by using some graphical tools of statistics, we convert that into a trend chart. That is now information. Now tell me, from the trend chart we can understand that, okay, now the trend is going up. Are you understanding? Now the trend is going up. So if I would not have converted that into a trend, I would never have understood that, okay, it is going up over the period of time. Like our stock market, right? The stock, the rate of the stock which goes up. It's a trend. Now, why it is going up? When we investigate, then from that investigation, what we get is actually the wisdom. That, okay, because we have changed the raw material, okay, because of we have automated the process, okay, because of this, because of that. So now whatever, so then we understand, if we do this, then we can get this kind of a trend, and that is called as a wisdom. So data converting into information and information converted into wisdom is this entire science. And through this Lean Six Sigma, what we are getting is the wisdom about our process. Are you understanding? Ultimately, our overall consciousness, our overall understanding and the wisdom about our own process should go up. And that is the ultimate purpose of doing this entire exercise. Okay, now how do we do that? So let's decode statistics further. When we enter into statistics, what happens is, look at this. When it comes to statistics, there are two parts of statistics. One is called descriptive statistics, other is called inferential statistics. Descriptive and inferential, there are two types of statistics. Now we have seen two types of data, continuous and discrete. That data goes into statistics. There are two types of statistics. One is descriptive, one is inferential. What is descriptive? Descriptive is about a small sample. For example, let me give you an example of which I always give is when we see a cricket match. Let's say recently India and South Africa match was going on, right? Now there is a T20 cricket match. 5 overs, 40 runs and 1 wicket, if that is the score. That is a small sample of 5 overs and this is the current score, and this is called as descriptive statistics. And when we are observing the match, when we are seeing the match, on the same side, below there is something called projected score. Now in the projected score, they write like this. If they continue, scoring like this, they might reach to 160 runs. If they increase the scoring rate, they might reach to 170 or even further 180. And this is called projection of the score, projected. So from a sample of 5 overs, they are projecting the performance of 20 overs, and this is called inferential statistics. This is called descriptive, and the projected score is called inferential statistics. Are you clear with this? Just give me a yes in the chat box. So descriptive is about the past, inferential is about the future. Descriptive is about the sample, inferential is about the population. When we are not well, we take the blood sample, right? So in the blood sample, all the report we get, right? WBC count, RBC count and cholesterol levels and all those things, right? That is called descriptive statistics. And from that small sample of our blood, doctor, assumes that this is, let's say, infection is there, some viral infection is there from the blood report. That means doctor assumed that our overall body blood must have got infected because of this particular virus. Okay. So descriptive is a small blood sample we have taken and the report we have taken, and the doctor which is seeing the report of the descriptive statistics and then doing the medication accordingly is called inferential statistics. Clear? Yes? Everybody's clear about this? Descriptive, inferential, just give me yes in the chat box. Just for your understanding, this is what we are. So inferential may in green belt, black belt level, okay, descriptive may we are going to see the central tendency and dispersion. Inferential may we are going to see correlation, regression, hypothesis testing, process capability analysis, confidence interval, all these things, design of experimentation, everything falls into inferential statistics. And in descriptive statistics, we have mean, mode, median, range, variance, standard deviation. Okay. Now, coming back to descriptive statistics, here, everybody understands normal distribution curve, right? So, in the normal distribution curve, this is the center of it. We call it as mean or X bar, let's say for example. Okay. Along with that, this is the spread of the data, the range or the spread of the data, and both are very, very important. Why both are very, very important? Just try to understand this with this analogy. Okay. Just try to understand this analogy. Let's say the temperature of tea. Okay. Now, customer says, I want temperature between 70 and 90 degrees centigrade. So the target customer has given is 80 degrees centigrade. Upper specification limit is 90 and lower specification is 70. So customer will accept the cup of tea within 70 and 90 degrees centigrade. Below 70 degree it will be too cold. Above 90 degree it will be too hot for customer to consume. Okay. Now understand this. If we have what you can say process like this. This is my process number 1. Okay. Let me draw 3 processes for you. Again, this is 80, 90 and 70 degree. Second process, let's say, is here. Okay. And this is my third process. Again the same, which is 80, 90 and 70. This is my third process. Okay. Just try to understand this. So here, understand this. Here, the first process having huge variation. So the spread is very high. Even though the mean is matching with the target of 80, the center, the mean is matching with the target, but the variation is very high. When I say variation, I am talking about dispersion. When I say mean, I am talking about the central tendency. Where is the center of the data? And both parameters are very important. In the second case, try to understand this. The dispersion is very less. The spread of the data is very less. But the mean is not matching with the target. There is a huge distance between the mean and the target. So this entire thing is rejected. It is too hot for the customer to consume. Here, the data of this side and this side will be rejected because it is above and below the specification limit. On the third occasion is where the data is matching the target and the spread is also very much limited. That's where central tendency, the mean is also important, and the dispersion, the spread of the data is also important for us to measure. Both these parameters are important for us to measure. Are you clear with this example? Just give me yes in the chat box. Anybody who has not understood, please let me know. Don't type yes because everybody is typing yes, okay? If you have not understood, I will explain it for you. Simple hai, very easy, easy peasy. Now, very good. Now understand this. Let's go deeper into central tendency and dispersion. Okay. So today we will discuss about how the central tendency is calculated and how the what you can say the dispersion is calculated. Okay. Okay. Who is this by the way? DW. आपका नाम एक बार फिर से डाल दीजिए. DWQ. हाँ, मुकेश जी मैं रिपीट करता हूँ. See, understand this. If, let me undo this. Okay, look at this. So I have explained. Okay, nice name. Okay, see what I gave 3 examples of the tea. In the first case is my lower specification is 70 degree, my upper specification is 90 degree, correct? Now, in the first, let's say, first process, there is huge variation of delivery. Sometimes people are delivering of 60 degrees, sometimes at 100 degree. So whatever is below 70 degrees rejected, whatever is above 70 degrees rejected. So above 90 degrees rejected. So when the spread, the dispersion is very high, there is more probability of making defect. Okay, so dispersion is also very important category or part to be considered. On the other side, where is the mean? Let's say second case, the dispersion is very low, but the mean is not matching the target. This is target, no? So there is huge difference between the mean and the target. So the central tendency not matching is also not advisable. What is advisable? What is the best option we have is the central tendency matching with the target, and dispersion also is very low. That is what we know. That is what we want. That's why measuring the central tendency and measuring the dispersion, both parameters are important. Clear? Mukeshji, just give me yes. Clear, everybody? Just give me yes in the chat box. Okay?
So actually, I have
Huh.
one question out here, if you allow me. So basically, while selecting, project, or maybe what are the scenarios wherein we need to consider either central tendency or dispersions? So based on what we are supposed to select the target project.
No. Can you just come again? Can you just come again?
What I'm saying, let's suppose if I look at the scenarios, like, so in which scenarios I'm supposed to, consider central tendency or dispersion?
No. In all the scenarios, you should consider both. Both are very important. Central tendency is also important and dispersion is also important. As we go in the next part, you will understand why it is so important. Okay, so from this example, you must have realized that, okay, if I only measure the central tendency, okay, like this, okay, in the first case, that may not be sufficient because in that case the dispersion is very high. So I'm generating defects. On the second case, if I only measure the dispersion, that is also not the right strategy because I might go outside of the specification. My dispersion is very low. Okay, but I'm going outside of the specification. That's why always consider both things. And for us, we have Minitab software with us. Just put the data, it will give everything for us, which is important. Clear? Yes, accuracy and precision. That's the same thing, Santoshji. We need accuracy with precision. Both are very, very important. Are you clear? Yes?
Yes, sir. Got it. So dispersion is all about spread of the data, right?
Correct. Absolutely right. Dispersion itself is the spread of the data, and central tendency is where is the center of the data. Yes?
Got it. Thank you, sir.
Superb, superb. Now, going further, let's go deeper into. Yes. So, anybody who has got it now? Very good, very good, very good. So, we need both accuracy and precision both. And the third case, we got both accuracy as well as precision. Now let's go a little deeper into central tendency. Let's talk about mean, mode, and median. Okay, and then we'll see what is standard deviation. Okay, now the mean is simple average. There are three ways we can calculate the central tendency. One is the mean. Mean is simple average, which we all understand. Arithmetic average. Collect the data, add everything, divide by number of data points. Simple, like this. 500, 750, 600, 450, 775. We add all the production numbers, divided by 5 is equal to 615. That means average, on an average, we produce 615, tons production or, kilogram, whatever. Okay, simple average. Mean is simple average. Next one is called mode. What is mode? Mode is maximum occurring value of the data point. Okay, maximum occurring value of the data point. Now let's look at this data point. And what is the maximum occurring value here? Most repeatedly occurring value in this data set. That is called mode. Very good. It's 75 because 75 has come 1, 2, and 3 times. So 75 is a mode here, right? So how this distribution will look like? So let me draw this distribution. Okay. So on the x-axis, we have data starting from, let's say, 60.
Sir, I'm so sorry to disturb you. I'm getting one pop-up, but the meeting is being transcribed.
It's okay.
I'm not able to. But I'm not able to see the full screen actually because of this pop-up.
Okay, you can just click on OK. That will make it full.
Done. Thank you. Thank you, sir. I'm sorry.
80 and 85 and 90. Let's say this is my x-axis. Now, so I have got 160. So I will just plot it. Okay, and यहाँ पे I will just write 1, 2, 3 kind of thing. This is the frequency. Okay. So let's say 60 is 1, 65, I have got 165, I have got 67, so I will just combine them into 65. So I have got two 65s here. I have got no 70, but I have got 375. So 1, 2, and 375s I have. I have got two 80s, so I have got two 80s here. 85 में कोई है? No, I don't have anybody in 85. I have got just one in 90. So if I make something like this, I will get a distribution like this. Are you understanding this? How the distribution is plotted? Just give me yes in the chat box. Okay, so the highest amount of frequency is 75. So this is called my mode. So in the normal distribution, actually, okay, mean and mode are very close to each other. They might be equal, but they will be very close. They might not be exactly equal, but they will be very close to each other. So the peak of the normal distribution curve is called the mode. It's the highest frequency. Clear? Very good. Now let's talk about median. What is median? Median is if I arrange the data set in ascending or descending order. If I arrange the data set in ascending or descending order, okay, let's say this is the original data set. I arrange the data set in ascending order, lowest to highest. The central value of that is called as median. Are you clear? The center of the value is called median. Are you clear with this? Just give me yes. Mean, mode, and median. Are you clear? Just give me yes. Okay. Basics are clear. Very good. Now, what we have seen is this one. Okay. Central tendency curve. On the left hand side bottom, you can see mean, mode, and median we have seen. Now let's talk about what are the measures of dispersion, which is range, variance, and standard deviation. Okay, let's have a look at range, variance, and standard deviation. Okay. Now what is the first one is the range. Range is nothing but the highest value minus the lowest value, the difference between highest and the lowest. Let's say if we collect the weight of the people sitting in the room, somebody will say my weight is 50 kg, somebody will say 60, somebody will say 65, 62, 70, 80, 90, 100. So the lowest is 50, highest is 105, let's say. So the range is 55 kg. Highest minus lowest, simple. Okay, this is called the range. The next one is called variance and standard deviation. Let's try to understand this. Okay, so similar to what we have done earlier, this is a histogram or a central tendency distribution. Okay, now what we do, first we calculate the mean of the data. So imagine this is the mean. Okay, x bar is the mean, center. From the mean value, we calculate the distance between each and every value. For example, this is distance 1, this is distance 2, this is distance 3, this is distance 4, this is distance 5, etc. Okay, so every data point will have different distances. Okay, but now what happens, because some of the distances are on the plus side, on the positive side, some of the distances are on the negative side, which are on the lesser side, right? So for example, so d1 might be plus 1, d2 or d3 might be minus 1. Are you understanding this? Just give me yes in chat box. Clear? So because 1 is on the plus side, for example, let's take an example of same this one. Okay, अपना t वाला example लेते. So 80 degree is my target. Okay, so if I take one cup, that temperature is 70 degrees. So I just make a, okay, and the second is 90 degree. No? So let's say my mean is 80 degree. From my mean, if something is greater than my mean, that will be a positive distance. If something is lesser than my mean, that is on the negative distance. Yes or no? So if the difference between 70 and 80 will be minus 10 degrees centigrade, 70 minus 80 will be minus 10. 90 minus 80 will be plus 10. Are you understanding? Plus and minus, simple. On the left hand side it's minus and on the positive side is plus. Now, what they do to basically eliminate this effect of plus and minus, statisticians take the squared value of it. Okay, statisticians take the squared value. So instead of d1 and d2, they will take d1 square. Why? Because the squared value is always a positive value. Okay, so here what they do, they take these squared values d1 square, d2 square, d3 square, d4 square, etc., and then they take the average of it, and that average of the squared value is called variance. Here you can see the formula. Variance is d1 square plus d2 square plus d3 square plus d4 square plus d5 square d6 square d7 square, all divided by number of data point. It's called variance. Variance is denoted like sigma square. Why square? Because we have taken the squared value just to avoid this positive and negative clash. Are you clear? Now, because we have taken the squared value, we take the square root of that, and that becomes the standard deviation. Standard deviation sigma meaning square root of the entire variance value. Clear? So this is the formula for standard deviation: d1 square plus d2 square plus d3 square up to dn square divided by n whole, square root of the whole entire number. Clear? Just give me yes in the chat box. Have you understood the formula? Just give me yes. Take down the formula. This is the formula. You don't have to remember this, but understand from where this formula has been derived. Everybody with me? Now, what is the meaning of this? What is the meaning of this standard deviation? Let's try to understand this. Okay. Let's try to understand the meaning of this formula. And to do that, let's take one practical case. Okay. Please bear with my handwriting. Just take a practical case of this. Let's take these 5 data points: 10, 12, 15, 18 and 20. So first step is, we'll take the average. First the mean. So mean of all these data point is 15. Okay. So mean is 15. Then we are taking the distances d1, d2, d3. So for example, here the d1 is